Okay, so this is a detailed manual calculation of system of nonlinear equation from the previous video. I think I didn't show the derivation, or rather the specific partial derivatives of the given two equation, which is f1 and f2. Okay, so remember, we have two nonlinear equation, system of nonlinear equation, f1, which is y minus 1 half e raised to x over 2 plus e raised to negative x over 2, while the other one is f2, which is equal to 9x squared plus 25y squared minus 225. And remember that uh, before getting the delta x delta y formula, we need to get first the corresponding partial derivatives, say df1 dx, df1 dy, and then df2 dx, df2 dy. Okay, first the df1 dx. Okay, so here y will be constant, so we know you don't need to find the derivatives of that. So we treat x as the variable, therefore e raised to x over 2, its derivative is 1 half e x over 2, right? Then e negative x over 2 is negative 1 half e raised to negative x over 2. And then simplify that, we got negative 1/4 open parenthesis e raised to x over 2 minus e raised to negative x over 2. For the df1 dy, now y becomes a variable. Okay, so simply df1 dy is just 1 because everything here on the second term is constant. Okay, next is df2 dx. So we treat y as constant, therefore our derivatives is just 18x. So using chain rule, right? 9 times 2 is 18x. Then df2 dy, we treat now x as constant, therefore 25 times 2 is 50, therefore, and then y. Okay, so after that we can now get the Jacobian, wherein the formula is the determinant of df1 dx, df1 dy, df2 dx, and then df2 dy. So if you lay down the corresponding df's here and then perform the determinant, you will get this as the Jacobian. Okay, so this is negative 1/4 ex over 2 minus e raised to negative x over 2 multiplied by 50y minus 18x, so because this is just 1. Okay, after getting the Jacobian, it's now time to get the delta x and delta y, wherein the formula is this. Formula is this here. Okay, now we will, in Excel, in implementation in Excel, I show you this in our ebook. Okay, you should lay down from the x, y, the f1, the f2, and then the df's. Okay, and then the Jacobian, then the delta x and delta y, which is something like this. Okay, so our initial x and y value is 2.5 and 2, so we simply substitute that on our formulas here, the f1, the f2, the df1, the df1 dx, df1 dy, df2 dx, and then df2 dy, and then the Jacobian, and then finally the delta x and delta y. Okay, for example, the f1, the equation is, remember, where is that? F1 is this. Okay, so substitute your x and y here. Same with f2, substitute the initial x and y, so goes with here these other formulas, and you will get this. Okay, for f1 0.116, for f2 you got negative 68.75, For df1 dx, negative 0.8. For df1 dy is 1 because 1 is constant. df2 dx is 45, and then df2 dy is 100. Then substitute now for the Jacobian, we have negative 125.096. Okay, and then implement that, all those values, substitute for your formula of dx dy. I rewrite these two formulas here. I rewrite that here so that you can see the substitution of the values here. Negative f1 df2 dy plus f2 df1 dy over Jacobian. For the delta y, negative f2 df1 dx plus f1 df2 dx over the Jacobian. Substituting all the values here above, you will get the corresponding delta x, 0.64 and 0.4 for the delta y. And then, so that means I can now check this. If you know all of the values here, so you have delta x and delta y, that means this value will now be here. Right? Okay, it will be here. So just 2.5 plus delta x, so that is your values here. 2 plus delta y, that will be your value here. And do the same operation as we did. That's why you need a spreadsheet in doing that, and then until you got your delta x and delta y correctly. So how will you know that delta x and delta y is correct? Of course, if your value is almost 0. Okay, so that's it for the system of nonlinear equation.